Welcome to the first CIV Talks. So as you would have known from all the emails that we've been sending, CIV Talks is basically a way for students at the University of Toronto in the civil engineering department to share the research they're doing, but to share it at a high level so that students from different specialties can understand what's going on and also join in on the discussion. So the point is to relate the research that you're doing to something that people can relate to, something to do with society. So for the first talks, we have the future of light rail transit. So we're going to talk with students that are doing research in this field from the transportation department as well as from the structural department. And they're going to try to convey what they're doing in terms of research, but do it in a way that is understandable to any civil engineer. So the three speakers we have for the first CIV Talks is Mohammed Mahmoud, and he's he's being supervised by Professor Shalabi and Professor Habib. And he's going to be speaking looking at the differences between LRT, BRT, and subway. And then we have David Hubble, who's being supervised by Professor Govero in the structural engineering department, and he's going to go through bridges that are used for LRT systems. And then finally, Samantha Hinz, who's also with Professor Govero in the structural engineering department, is going to talk about the transit in Toronto as well as comparing it to other transit systems in North America. So the point of these talks is to not only have it as a lecture style, but to get a discussion going between the speaker and the audience. So it's important for you to pose questions, pose them to the speakers, pose them to the audience, get a discussion going, and try to, a friend of mine used the term conversational knowledge. So we're going to learn off of each other. So without further ado, I'll introduce the first speaker, Mohammed.
Hi guys, my name is Mohammed, and thank you Rami for the introduction, and thanks SIGSAF for organizing the CIV Talks. I'll try to make the talking part as short as possible, leave more room for discussion at the end. But if you have any questions or comments, just stop me at any time. So before talking comparison between different modes, let's see first how do we categorize them. These are the three elements for any transit mode: right-of-way, technology, and service. Right-of-way is the most important or influence factor that we use to categorize transit modes because it affects the investment cost and the performance of the transit mode as well. It also interacts between the technology and service, as we will see in a minute. So we have three different levels of right-of-way. Right-of-way C, which is a shared right-of-way, typically used for transit, street transit, buses, streetcars. It shares the traffic with, or the way with regular traffic. The second one is right-of-way B, partially separated right-of-way. So we have dedicated lanes for transit units, but with at-grade intersections. So it's like partially separated on the way, but at intersections they interfere with regular traffic. That's used usually for semi-rapid transit, which includes LRT, BRT, high-end streetcars. Finally, right-of-way A, which is the fully separated right-of-way. That's for commuter rail, subway. It's a fully dedicated right-of-way even at intersections, as you can see at the different level, different grade intersections. So based on that, quiz. Streetcars are LRT, right or wrong? Wrong. Yeah, they are not. See why? Daily double. What does the R in BRT refers to?
Rapid.
Is it? That's the best wrong answer ever. So it's rapid by definition, but it's not rapid in reality. They are semi-rapid transit. We'll see why in a minute too. How about LRT then? So LRT stands for light rail transit. Are they rapid or semi-rapid? Right? So semi-rapid, yeah. So how do we define that? So if you look at this chart here, you have investment cost at the y-axis, the performance at the x-axis. So here where right-of-way C modes, streetcars, poor performance, low investment cost. You go higher a little bit with coast, you get more performance, BRT, LRT, and then at the very end, you can get light rail rapid transit, which is the higher end, like the higher level of LRT vehicles. So like LRT vehicles running on subway tracks. That's the difference between the two. And then you go for right-of-way A, where you have subway, you have commuter rail, very high investment cost, but comes with best performance. So quickly, what is the differences between streetcars, light rail transit, and subway? So these are running on right-of-way C, B, A. The average speeds are 10 to 20 kilometers per hour, which you can usually bike faster than this. And LRT, it's higher speed, 30 kilometers per hour, and subway goes up to 40 kilometers per hour. The capacity increases from streetcars to LRT up to 40,000 passengers per hour per direction for subway. And then the stop spacing is also increasing from streetcars, LRT, and subway. That means like more accessibility for streetcars, less for subway, but faster travel time for subway than streetcars. And then the cost is a very important factor here, because when we talk about streetcars, it's like less than $100 million per kilometer, but for subways, it's more than $300 million per 1 kilometer. That's too much. So if we don't need subway, and we just like use streetcar or LRTs, think about the saving in money that you can use to increase the system accessibility, or so you can go further, create more lines with the same amount of money, but with less capacity or less performance transit mode. There are like two differences between streetcars, LRT, and subway. So those take the the power from overhead cables. In subway, it's mostly from the rails. Streetcars are different than LRT in a way that streetcars you need a loop to make a U-turn at the terminal stations, but for LRTs they are double-ended trains like the subway, so it saves time at the terminal stations. LRT and subway, you can see here like boarding at the same level of the train. Streetcars, you have to climb the stairs. So major differences. So again, same thing between our LRT and BRT. So if you think of BRT, think rail, do bus. So it's the same idea of doing light rail transit, but on a street, not rails. So this has actually a better performance with the same passenger volume, because it's faster, has more capacity, and it has lower operation costs as well, because the more capacity have less number of vehicles you need, and that includes the most expensive part of the running a transit system, which is the driver cost. So you need more transit vehicles here, you need more drivers, it's more costly. But BRT has its own pros as well. It has lower number of transfers because you can easily plan lines, more flexible, and they have lower investment costs, no need for rails, just buses, and a curb. And then less implementation time, so you can do that in a year or two, compared to light rail transit needs more than that. So, silver bullet? No, there's no silver bullet. There's no answer which one is the best. Each mode has its own domain of applications. It really depends on the passenger volumes, financial resources, and also urban space. So you may have the financial resources and the passenger volumes that requires or require LRT, but you don't have the space to do that, and you end up doing like streetcar or a bus. So it depends on which one of these do we need, or based on these, we define which one do we need. So if you have any comments or questions, talk to me now or later. And then I'll hand this to David to talk more about LRT, because it seemed that it was the best option.
So yeah, I'm talking about structures for elevated light rail, which I guess would fall into the light rail rapid transit category, LRRT, because the purpose of the elevation is to achieve right-of-way A, I guess, to avoid the need to stop at intersections and to achieve the robustness and efficiency of the transit system that you can get by separating yourself from the road network. And Mohammed also alluded to the fact that often subways are preferred over an elevated system because they're less visible. They make less of an impact on, I guess, the urban fabric or the neighborhoods that it passes through. So there's an opportunity for a structural designer to work to make a structure that can be visible, that can be elevated, but that can be a less of a negative impact on the neighborhoods that it affects. So to start a discussion about those kind of ideas, I'm going to present two existing elevated systems, both in Vancouver. So the first is the Expo line. I went on Google Maps and I tried to find two views of these two systems that we can kind of compare. So this is the Expo line, built in the mid-'80s for the SkyTrain system there. And the second is the Canada line. This was built for the Vancouver Olympics in 2009 or so, also for an extension of the SkyTrain. So basically the same cars, same system. The only thing that's really different is the time at which they were built. So just from a visual comparison of these two systems, you can have your own opinion, but I think it's definitely clear that the older system is much more slender. When we talk about slenderness of structures, we talk about a span to depth ratio. So the ratio of the depth of the girder, not including the barrier, to the distance between the piers. For the old Expo line system, it's about 25 to 1, and for the newer system, it's 17 to 1. And just looking at them, I mean, it's a slightly different situation, but you do get the feel that this is a bigger imposition on the neighborhood than the older system, which begs the question: why have we moved backwards? Why has the industry moved away from this structural system towards this structural system? So to understand that, and then, from my perspective, the thinking is, well, are there opportunities to use new materials, new methods, to move back towards a system for elevated structures that can sort of recapture or even improve upon the aesthetic merits and the efficiency of the Expo line? So I'll briefly describe the construction method for these two systems, which gets at the differences and why maybe they've abandoned this and what maybe we need to do to get back to a system that has the merits of this one. So this is a system of precast girders. So everything you see in red there is cast in one piece in a precaster's yard, and then that's shipped to site. The piers are cast in place, and then basically you just have a crane, you pick up each girder in one piece, and then you, at this point here, there's an expansion joint, so it sits on bearings. Over here, you'd support it on some temporary false work, and then you'd pour your closure joint. So these girders are continuous over typically 2 or 3 spans, which adds to the efficiency of the system. The drawback maybe of this system is that each one of these girders weighs about 100 tons, which is a substantial thing to transport, to pick up, to move around, to line into place, especially when you consider that they're not all straight. So the way they fabricated these girders was they had special formwork specifically for this project that was articulated. So they could arrange the segments of the formwork to form a curve in plan or a change of elevation or twist, whatever was required for the alignment of the track could be matched with the girder. And that the advantage of that is that it moves a lot of the fabrication effort away from site where you're imposing on the neighborhood to a precaster's yard where it's controlled conditions. You can set things up. You have more control over the fabrication process. But I think a problem that they had with this was that these big heavy girders, especially the ones that are curved, were kind of difficult to transport to site. They probably needed special permits and police escorts, that kind of thing, which adds to the cost of the system, right? So with the newer line, and with many, like not just in Vancouver, but there's a new line in Calgary that's built. It looks almost identical to this. There's a line in London, England that again looks almost identical to this. So it really is, the whole industry is kind of moving towards this kind of system in the last few years. And the reason for that is that this is precast segmental. So rather than having precast girders, just what's highlighted in red there is cast in one piece at site, or at the precaster's yard, sorry. And then these segments are shipped individually to site, and then there would be an overhead truss that would sit on this pier, and this pier. And then if say this span was already constructed, so this span would have a truss over top of it, you'd bring all of your segments in, they'd all be picked up, supported by the overhead truss, and then they're post-tensioned together. Then you grout the tendons and then set it down, and then you move your truss over so that it's ready to make the next span. So that's a system that's called span by span precast segmental construction. And it's a procedure that's used fairly commonly for highway bridges as well. So contractors are familiar with it, and it has the advantage that each of these segments, rather than 100 tons, is 25 tons. They're all the same size, they're all the same shape. They're 3 meters wide, which is within trucking clearance, so you don't need special permits to move them around, typically. So I think that's probably the reason why we've gone to this system for most recent constructions over the earlier Expo line structural system. But there's no denying that I think if it was me owning this car dealership, I'd be happier with this passing over my lot than something like this. So with my own research, I'm looking at how can we get back to a system of precast girders, and how can we use new materials like ultra high performance fiber reinforced concrete and fiber reinforced polymer. So materials that have higher strength and higher stiffness per weight. So we can make a girder that rather than weighing 100 tons weighs, say, 40 tons. So now, you pay a lot more for the materials to make the girder, but there's a lot of trickle-down savings associated with the lightness of the girders. So you don't need post-tensioning anymore. The cranes that you need to lift into place are lighter, easier to find. And so the hope is that we can use these new materials in a smart way to make the elevated option of achieving, I guess, right-of-way A more palatable for those who have to pay for it. So, any questions? Yeah. Thanks.
looking at a lot of structural and really analytical ways of looking at things. I just want us to take a step back and think about the fact that at the end of the day, people are going to be using these systems. And obviously, one very important fact about that is that in order for these systems to be successful, you need to have people to ride them. And I want to talk a little bit about what I have seen as the important factors in ridership based on my own experience. I want to sort of clarify that this is all based on my own experience and not necessarily about a lot of research. So I welcome other views, and if anyone else has any input from systems that they've been involved in, I really want to know about it because I find it very interesting. So I've grouped this into two different sections. The external ridership factors, I'm thinking how close the lines are to things, how frequently they run, how reliable the system is, how quickly it is, how quickly it gets you places, the convenience of the system. And then internal factors are more station specific, so the appearance, safety, prices, those kinds of things. So I'm going to focus on three systems that I'm familiar with. New York City, the largest metro in North America. Mexico City, which is the second largest in North America. And if I were to go to the third largest, we'd get into Montreal, but I don't know much about Montreal, so we're going to focus on the TTC, which is fifth, I believe, in North America. So based on these maps, you can see that in terms of proximity, New York City has a lot covered, and this is really only Manhattan, Brooklyn, Queens. You get into the Bronx and Harlem, and you can get basically anywhere in New York City. Mexico City, I find that their metro system is a lot more sprawling, a lot less dense. They have intermediate systems that help you get between the major lines, but Mexico City is huge, so they sort of had to spread out. And then we have the TTC, which has a few major lines, and then the streetcars, which I find they work, but they serve a purpose. So that's proximity. Frequency, New York City, very frequent, I find, pretty reliable. The thing is that frequency and reliability, I think, come hand in hand. A system doesn't need to be as reliable if you're going to be getting trains all the time, right? If you're not as frequent, then your times need to be spot on. I had an experience in New Jersey where I needed a bus, but my bus just didn't come, and then a sketchy, what my friend calls Mexican bus, came by, and I had got on it, and she was like, "You'll get to the airport, don't worry." And I was like, "Okay." So I mean, reliability, it's sort of hand in hand with safety. If you know your bus is going to be there, then you're fine. But if it's not going to be there, then what are you going to do? With that, it also depends on what your aim is, where you're going to get people. So here, it's mostly based on downtown, right? And that's the same with New York City, Manhattan, everything goes through Manhattan. I am from Saskatoon, and I also went to school in Syracuse, and they had two very different systems. In Saskatoon, almost every single line goes through the university, whereas in Syracuse, there's only one line that goes from the university to everything else. So they've taken two different approaches to get university kids. You can either take one line and get the university kids to the major system, or you can take everyone to the university. And that, I mean, it's just different things to think about. Then efficiency, that goes more with what these guys were talking about. If you're going to be sitting in traffic regardless, then it's it's not really a plus if you're going to be sitting in a bus in traffic, or if you're going to be sitting in a car in traffic. The only real major benefit of that is that you're not driving. So I mean, a lot of people find that beneficial, but you're still wasting time. And then lastly, convenience. The thing with that is that public transit is obviously not very convenient in terms of having a lot of things that you need to carry with you. I think groceries or a bike. The nice thing about buses is that you can sometimes put a bike on them, but with subways, it's not really easy to carry a bike downstairs and into the subway. But so that's another issue. And then the internal factors for station appearance. I find that sort of like apparent safety. So people, like a station can be completely safe, but if it looks dark and scary, people are going to be less likely to enjoy riding. People aren't going to want to ride. New York City, I find, has some pretty dingy looking stations, but they also, I saw a lecture by one of the ladies who actually plans the rehabilitation of those stations, and each of those stations has a 40-year turnaround before they get looked at again. So they do about 10 stations a year, and then that station, once it's rehabilitated, doesn't even get thought of for another 40 years. So, I mean, that's a problem with a big metropolitan area like that. Mexico City, I found, has pretty nice stations, actually, but they're way overcrowded. You literally have to like push your way onto a train and maybe fall off. Like the trains just go by that you can't even get into. And then safety, that's both actual safety and perceived safety. There are some things that you can't help. People jump onto subway lines. People are just dangerous people, and you can't really help that. But the one thing that I liked about Mexico City is that they have dedicated women's only trains. The front train of every subway, you can go into that train, and that's women's only. So that's nice when it's late at night and there's sketchy people on the subway. They also have some women's only buses, but those are only those are dedicated times. You need to find the schedule for those. My favorite is fare systems. So there are some pretty sophisticated fare systems in North America. Philadelphia and New York City are about to input RFID tags so that you can just like swipe or like flash tag and it'll get you through. Toronto still has tokens, which I find just hilarious. But you know. And then fare prices. New York City is $2.75, $3 for a subway. Toronto is about the same. Mexico City is 10 pesos, which is 25 cents. Well, I lied. It's 3 pesos, but it's 10 pesos if you want a reloadable card, and then after that it's 3 pesos. So it's like 25 cents, maybe 75 cents to get on the train, and they have a huge system, but it's really cheap and everyone uses it. And then lastly, the connotation. I find that this is sometimes a thing, and I'm not sure why, but people feel like ashamed of using public transit, and that's basically something that I think that our public transit lines speak for themselves, and they're their own kind of marketing. So I guess if we want people to use them and we want them to improve, then we need to make them better. And it's sort of this push and pull. Like if we make them better, people use them, and I think that's the underlying sort of message, I guess. So, and then extra bonuses, New York City is putting Wi-Fi in some of their stations, so that's nice. And then obviously New York City has bus and train trackers. There's only one train, I think, that doesn't have live tracking. It's the L train. And then the RFID, as I explained before. So lastly, I'd love to hear your input on the trains that you've been able to use and the systems that you've been able to use. And then also, Rami wants to hear more about what we can do more CIV Talks about.